Hello, my friends, and welcome to another exciting episode of the AI Show. If you didn't know, this is the AI Show. I'm pretty excited to be here. Where's everybody coming to us from today? I'm taking a look at the chat here. Say hello to me. We have some fun stuff today. We're going to get some stuff done. And we get to code together for a couple of hours. Feel free to pop in and out, ask some questions. This is all for you. Although I do want to get my game done too. So hopefully everyone knows that we're trying to get stuff done too and have fun. AI, oh my goodness, from Daytona Beach, J-Star. J-Star from Daytona Beach. Welcome. Sashin, hello, my wonderful friends. Good to have you. Andy Leonard. Coming all the way from LinkedIn. Everyone wears ties over at LinkedIn because, you know, LinkedIn. Farmville, Virginia. Andy, welcome. Meron Aliyari. I don't know if I said that right. I tried to make it sound cool, but if I said it wrong, like, hey, dude. Woohoo, AI Friday is right. Yes, AI Friday. Hello from Pakistan. Welcome, my friend. And always to keep us honest, DF Mera. Bienvenidos. Todos. Hello, Charles. Good to have you, my friend. Where's everybody from? Also, another thing that I'm interested in is, what is your proficiency with AI, so I know what to explain and what not to explain. Otherwise, I just get all involved with stuff, and then it's like, do we even know what Seth is doing? Do I even know what I'm doing? Should we ask Cartoon Seth? Wow, that was a really strategic little focus it did by itself. And now back to me. That was cool, camera. Thank you, camera, for doing that work for me. I wonder. Wow, I mean, seriously, that camera is like reading my mind. Desde el país del tango music, Argentina. Bienvenida, Ivana. Geneviève. Bienvenue, mon ami. S'il y a quelque chose que je peux faire pour vous, tu me dis. That was bad French, but that's what we get. All right, so today it's time to get our handy dandy chalkboard, whiteboard deal and tell you, I should have put this up here so I could reach it. There's like a little stain on it too. So embarrassing. Thank goodness it's Friday. Here we go. We are going to start with our favorite contrast color, light gray on black. Number one, let's do a little review of what we're doing. You know, just for kicks and giggles. Number two, I actually went to Torch Vision and saw there were some models we have not tried for rock, paper, scissors. So we're going to expand our experimentation. I just wanted to do this twice. The alliteration with two letters. Quadliteration. And then number three, I was hoping to get some inference done with Node. So we can finally be on our way. And if we get this stuff done, then we're just going to start adding features to our website, make it so people can go and start playing with the actual stuff. So that's what we're doing today. I'm excited to be here. Brasil. Alex, muito obrigado. I don't know very many languages. I like fake a couple of them. If someone wants me to fake a language, just let me know. We actually have an AI service that lets me speak in other languages without having to know them. It's like Star Trek type stuff. All right. And then the next question I have for everyone, Sharnish, welcome. The next question I have for everyone is this: your comfort level with AI. And we're gonna do medium. I don't know. Maybe we should go by flavor of your beef. Do you like it medium? Medium rare? Well done? That's what I'm wondering about. I'm interested in your thoughts on that. And if I look over, it's because all your comments are over here, and I want to make sure that I get them. Try finish. J Star says try finish. J Star, I've been trying to finish this project for a long time. Yeah, I didn't. The computer didn't freeze. I was waiting for everyone's raucous laughter. And maybe some clapping. I don't know finish. Let me see. Let me see if I can find something. Finish pronunciation. Okay. How to pronounce Finnish. Pronouncing Finnish will certainly not be the hardest part of learning the language. There are some very simple rules that will facilitate the understanding of the phonological system of this language. First, stress in Finnish is completely predictable. You stress the first syllable in every word, regardless of its status, either as a native Finnish word or as a foreign borrowing. Second, there exists certain phonotactic constraints in Finnish. There can never be more than one word initial or word final consonant. The word franska, then, would have to undergo a change because the cluster fur is not allowed. That was, how'd you like that? There was a little finish there for you. What about ML with AI? Yeah, we're doing all the MLs with AI today. Jay was like, I knew that was coming. Yes, Jay, thank you for knowing. Pablito Piova, bienvenido. I'm just guessing because his name is Pablito. So maybe that's a little geocentric of me. Apologies. All right. So let's review what we're doing here. And then we'll get to it. And please ask your questions and stop me at any time. We're gonna spend the first little bit reviewing, like I said, do some models, and then see if we can get our inference to work. We ended last week, if you recall, me trying to get this thing exported, and we were just waiting for it. You know, like, are you done yet? Our inner voice was like, and it finished literally right when we had to end the show. So that was a bummer. But it actually finished. So here it is, our endpoint. Our end point. Let's test it. Blue deployment. Sometimes I gotta look on Teams because they're like, hey, you should do this or talk about that. Oh yeah. Okay. So basically we just have to send it an image and see what happens. Image equals boop boop. Let's go to our, I think we had like a little test function here. Not this one, you goober. Score. Oh, here we go. Here we go. This is the one. Let's open this little beauty up. Boop. Boop. That's me doing the rock. Way to represent, past Seth. Power to the people. So we'll take this rock here and we'll put it in here. And we'll see if it works. Boom! Yeah. Way to go, background music. Yeah, that's what we built. We deployed it last time to this thing. I don't want to hit consume because then all my keys will be exposed. and ain't nobody got time for that. But you can monitor it, monitor it. Request per minute. Let's refresh it. I don't know if this counts as a. Oh, jeez, it went away. Image. The other thing is that we're actually sending bits to this. So, boop. Let's try paper. Pop hair. Pop her. Oh, it says it got rock. How close is it? Ooh, close. Is this even a paper, though? Did I give it a picture of a... Better be me doing... Yes. Dang it. So not the best model. Scissor. There's me doing scissors. Let's see if it works with scissors. Whoop. Yes! But these are not... I don't know. I'm not feeling this. Not feeling this. Like, these are way too close, these numbers. Welcome, everybody, coming from various and sundry places across the world. All right, so I think our model is a bit cruddy, if I'm being honest. So let's take a look at it, what it's doing. Please reload Visual Studio to get the insider's build of Pylanth and the Python extension. All right, I will. Look at that. All the new bits up in her. This is the inference code, if you're wondering. You can see that there is an init call and a wildly decorated run call. And then this is just for me testing locally. So init basically loads the model. Let's make sure, yeah, and I have some global things to keep these things in memory. This is for Azure ML. Like if this is set, this is telling, if this environment variable is set, it's telling me, oh, this is running in the cloud. So let's just use that path and then add the model folder to it. Otherwise, we're just going to use outputs.model, which you recall. Did you recall? Está aquí, outputs.model. What model is this one? Anyways, I should probably output in the meta classes what model this is. You know what I'm saying? But I guess here it would tell me too. No, it's not telling me. Maybe we need to fix our. Let's fix our AI code so that it actually outputs the model type. That way we have more information about what's going on. Because I suspect, that we need to do some more model. Let's do some model stuff. So for those that are wondering what I'm doing, I'm basically building an AI model that looks at pictures of me doing rock, paper, scissors, or none. So here's me just sitting around. Oh, in the dark. Here's me sitting around just being like, what's up? It almost looks like I'm chewing on something. Let's get a little close. Is this too... This is uncomfortable for me, even. Here is... I made myself have a giggle. Here's me doing paper. Or being an extremely efficient crossing guard. You know, for the children at school. Sir. 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 There are children here. Jasmine comes from the .NET world. No experience with AI. That's okay. I have some experience with AI. Here's me doing the rock. Doop. The rock. Yeah, pound it. Pass Seth. And then paper. Or sorry, scissors. This is me doing it crooked. This is me being like, what's up, bunny ears? Man, past Seth is looking a little constipated. But are you eating your fiber, sir? And basically we take these images and we're trying to make it so that when I give it a new image of me, it'll just predict it. Peace out is right, Ivana. Peace. So the code to do this is right here. We're using PyTorch Lightning to simplify. This is the code that like gets and makes the data the right way, puts the data in the right format. This here code gets the model, builds the model correctly. I think I'm. And then one of the things that's been bothering me, I should have got the clip, was when Burke Holland was like, "You have a 40 megabyte model? That's way too big." And you know, my inner child was like,
"Is it too big? Should I be worried about this?"
And I am. So that's what we're gonna do. We need to slim down this model somehow too. This here file takes a model from the file that we output, the Onyx model, and it scores it or basically does inference. So basically, this is what tests the model. And then this here handy dandy code marries this one and this one together to build the actual model. So let's take a look at the code here for y'all. This is the code for the data. It's just a class, right? You can see, I don't know why it's like that. There you go. So this just instantiates the data module, which is a PyTorch Lightning thing. And PyTorch Lightning is fantastic. So Sharafuddin is saying, do we really need to do coding like this? Instead, we can use AI tools. I mean, maybe. But the thing about it is, like, I don't know. I'm not a hand wavy kind of guy. I'm just not a hand wavy kind of guy. That's me hand wavy. I wanted to show how this actually works. You know? And even if you don't know, and by the way, this is to answer Sharafuddin's question. Even if you don't understand it 100%, I want you to be able to look at this and say, oh, I know what this is. The answer is yes. There's some tools that will do this for you. But I'm showing you how to build those. And Sharafuddin is 100% right. Like if your business is like recognizing them but not building the models, then you probably shouldn't spend time on it. You know, I mean, you don't have to do that. So great question. And again, I just don't like being hand wavy. Come on, that was funny. All right. So here's the data. Basically, it just tells us where's the data. What's the batch size? Batch size is the number of images per, for loop instance. This tells us to transform the image. You're probably wondering where all these numbers come from. This basically is saying, here, let me show you. I'm just gonna show you. So a picture, if you think about it, every pixel has 3 numbers in it. So it's basically like RGB. So it's basically like 3 of these together, like this. And so it's like this big matrix with multiple matrices in them. It's like a 3. J-Star's like, we are not amused, Seth. So what this does is, because those numbers are between 0 and 255, this normalizes these numbers so that they're between either 0 and 1 or -1 and 1. I don't know what this is. But the reason why I chose these is because I'm doing some transfer learning. Let's see, Torch Vision. And if we go to their models, here we go. Their models all require this transformation. All pre-trained models expect image inputs normalized in the same way. Many batches of 3-channel RGB images of shape 3 by H by W, where H and W are expected to be at least 224. The images have to be loaded into a range of 0 and 1, and then normalized using this mean. You can use the following transform to normalize. We're going to have to actually figure out how to do this if we're going to do it in Node. Because the images, remember, that we're getting from the website are all between 0 and 255. So, what's up? You getting your computer? My child here needs to get their computer. Can you believe? Look at them. Listen to all the noise they're making. Here we go. Okay. Oh, wow, that was nice. That was nice. Okay. So that's where those numbers come from. We're going to have to get more pointy about what exactly that means, so you can see that right there. This basically resizes it, center crops the image, makes it a tensor, normalizes it. There's our transform. And then we recognized last week that I was doing this all wrong. We have to do a target transform as well to do a one-hot encoding. That's what this does. And then we get the image folder. We get a train and a validation data set. And that's it. This is the code. It's not a lot. It's like, what, 20, 30 lines of code? Most of it's ceremony. So this is the data that we're loading up. Here's the model. We tried a number of different models. You recall when we were doing our experiments here. Here it is. We tried a... Gosh, I can't even see it there. We don't need all these other... We don't need this. We don't need this. We don't need this. I know it's training. No. Save. Okay. So we tried a ResNet 34, a ResNet 18, a ResNet 50, a MobileNet V3 small, MobileNet V3 large. Those are the ones we tried. Look, some of them took a little bit longer than the others. And I don't think we even got, like, the best. Oh, wow. Looks like the MobileNet V3 large got the best loss. Oh, no. Sorry. The ResNet 18 got the best loss here. So that's the one we put into production. But this one's still a little big-ish. And you're probably saying, well, what the heck size are you talking about, Seth? This thing. The output is a model, and it's an actual file. This, oops, what am I pushing? This is an actual file. Nice. Yes. What is going on? Why isn't this working anymore? Oh, no. Okay, exit. Oh, I did out. Oh, no. How do I get out of this? I did this before. Oh, there we go. I did it. He reminds me of all my Mexican family members. Yes! My mom is from Mexico, de Sinaloa. And I lived in Guadalajara, Jalisco. I went to school there from 3rd grade to, I think it was 5th grade? Or 2nd to 3rd, 1st to 3rd? I don't remember. I think it was 1st to 3rd grade in Mexico. I am half Mexican. That's why Blood Covenant and I are blood brothers. Hermanos. Frank Gates, welcome, buddy. So this is what I'm talking about. And I think we downloaded this model. Let's take a look. Let me show you sizes so you can get a sense for what these sizes look like here. Boop, boop, boop. Azure ML outputs. Let's take a reveal in File Explorer. Boom. Here we go. This is run number 2. Outputs. Model. This is 46 megabytes. This is just too big. That's huge. I wonder how big the other ones are. Let's see the other ones. Let's go to run number... Stop pushing buttons, Seth. Let's go to run number 4. Outputs. Model. Oh, wrong one. Outputs. Model. Oh, 10 megabytes. That's not bad. Run number 4. Was this run number 4? Yeah, this is run number 4. Let's see what let's take a look at what that did. Run number 4. Numero cuatro. MobileNet v small. Let's take a look at what metrics. Yeah, I mean, but see, accuracy is at 97%. Oof. We got to get a trade-off here. Trade-off here. I mean, model size versus accuracy. Because we're looking at what? It's like a difference of like 10 megs. 10 megs. Yeah, 10 megs versus 45. That's ridiculous. Oof. Let's take a look at the loss. Let's take a look at training loss. Oh, validation loss. You know, this isn't bad on the validation loss. It's just, ugh. I don't know. We gotta make an executive decision, friends. Okay, so there's that. So these are the models. Maybe I can get rid of this. Like maybe I don't need another linear layer. Maybe I don't need one. Let's take that out. And then we'll softmax here. We'll softmax. Boop. On dimension 1. We don't need that. No, we don't need no extra layers. We have too many layers. Return. You're gone. Luca is saying it ain't useful if it ain't accurate. A broken watch is right 2 times a day, but for the rest of the day it's useless. But what if it's right 97% of the day? And you know that time you're on the toilet looking at your phone, it just stops working during that time, and that's okay, right? Because that's fungible time. I don't know. What do you think, Luca? I worry. Like we're talking about a model that's 45 megabytes, and I'm trying to get this thing to do inference in the actual web browser too. Maybe we have a bigger model in the back end and a cheaper model on the front end. I don't know. What do you think? I don't know. Oh, is the screen really blurry? Let me control plus here. Is that better? I guess it would be good to win once. Here's one. I've got nearly 50 gigabytes of photos and videos. I'd like to separate them by years, folder, and me. My daughter's photos. Yes, you can actually build that. Another question is the difference in accuracy when the file size is considered due more to detail and bigger file? Maybe. I mean, let's take a look at the loss. Because that's the thing that's interesting to me. These losses are very not very different from each other, right? We're talking about like between the best and the worst. We're talking about 4 100ths. And Wee's telling me that the screen is blurry. If anyone's experiencing that, let me know. Like my internet didn't work for a second. I need to get a new router. That's why I need to get a new router. Now, incidentally, I do wire in, so there is that. So that's the thing that I'm looking at. Like the best and the worst, the loss function is the same, irrespective on all of them, right? The loss is the measurement between what it predicts and what the truth is. And we also did a one-hot encoding separation, so the math should work out exactly the same. So JSTAR, the file size isn't really having an effect because the ResNet 34 is huge, or the ResNet 50 is huge compared to the ResNet 34 compared to this. Oh, is it blurry? Dang. Maybe my internet sucks. Here, let me control plus this. Is that better? Sorry. Let me move this out of the way. Boop. Is this bigger? Sorry about that. I'll make it bigger. Thank you. And by the way, we thank you so much. If something is wrong, tell me, and I'll do my best to fix it. So yeah, that's the thing that I'm like the ResNet 50, the ResNet 34 is way bigger than the ResNet 18. This one is way bigger than the ResNet, and it's still getting a higher loss. Oh, Luca doesn't watch full screen. Are we not good enough for full screen? I'm going to tell Vanessa on the staff. She's going to be so mad. I'm just kidding. She doesn't get mad. She gets even. All right. I might control minus this because this is a lot. So that's what and I try to zoom in so y'all can see what I'm talking about, right? So this model is much bigger in terms of size and parameters, but as you can see, its loss is worse than this one. We want it to be 0, remember? Which is, you see that? And so model size helps maybe. And that's why it's called data science, because nobody knows what they're doing and you got to try a bunch of stuff. And you remember last time I was just like, all right, let's try a bunch of models. So it occurred to me that when we were looking at this, there were some models that we hadn't tried. Like we hadn't tried AlexNet, we didn't do a VGG, we did all the ResNet flavors, we didn't do any squeeze nets or dense nets. And again, these are all trained on ImageNet, which means that they're all equivalent. They all have to be normalized the same way. And you can see all the accuracy and stuff here. So I figured we'd try a couple of other models and see what that looks like. And then the other thing that I wanted to do is I want to get rid of this. And let's do this on the output. Let's do this when we save. Let's see what we do. In the meta.json, let's save the model type. So let's do this. Self dot model type equals, and then we'll put this like in quotes or something, that way we can, and we'll move this down. DenseNet, yeah, I know. I'm all worried about size. I'm like, let's just try all of them, even the ginormous ones. Let's just put GPT-3 in the browser and have it suggest stuff in a one-shot learning mode. How do we stuff 1.5? How many billion parameters is there in the? Hold on. How many parameters are in GPT-3? I forget. Where is it? There's a chart. There is a chart. Where are you, chart? I remember seeing you here we go. The GPT-3 small has 125 million, or the regular GPT 175 billion parameters. And this is floats, right? So how much is a float? Is it 8 bits? Multiply that. Is it 8 bits or 16? It's a float 16. So multiply that by 16. Boom. Load that up in your browser. It feels like sometimes my browser is loading that up, what are you doing? Are you reading GPT-3? So let's try some smaller ones here. I wonder if we can see this is telling us the accuracy, but it's not telling us the size. And then the other thing we want to do is I'd love to measure the size of the model so we can output it. So what I'll do then is we'll do this here. And then what we'll do is we'll save the classes. Here, that's what we'll do. We'll do this. Can we do this? Yeah. We're going to make it look like JavaScript because what the heck? Model. And then this is going to be self.model type. Model type. Why doesn't it like this? Oh, because I need a comma. No, I don't. Yeah, I need a comma. Okay. Okay. And then let's do this. Let's get the size of the model and literally just output it, like the number of parameters, Can it params? And then we can say something like, I don't know, self dot parameters. Is this what type of value is this? Go to definition. Parameters, it's an iteration, so let's do length on it. And then let's do size. That way, when we output these things, we'll just put 12. Oh, I forgot a comma again. Goofball. Returns an iterator over module parameters. Okay. So we'll say recurse. Oh, I wonder if this is gonna like. I wonder if this. I wonder if this is gonna make our training time bigger. I don't know. And then what we want to do is let's measure the size of a file on disk. Measure size of file on disk. Oh, Python. Oh, os.getSize. Look at that. Look at that. Beautiful. This. All right. Just in case. And then what we should probably do is we should probably log these, right? I wonder if there's a way to log. Yeah, self.log. Self.log. We want to do params, and then we'll just say, we should probably stick these in variables. We should lift them to variables. Param size equals this. Boop. Boop. File size equals this. We're trying to learn to be economical. And the other thing I want to do is I want to log these. Self.log params, and then we'll say param size, and then we'll say self.log. Probably driving y'all crazy. Size. This is probably driving you crazy that I'm like doing something like this. Seth, make up your mind. Okay, so let's do a little quick run through here. I think the large one took a long time. Let's do a ResNet 18. We don't need this one. So .ResNet 18. That's the one we thought we would do. Okay, and let's do Python. Oh, we need to activate Conda. Activate torch. Boop. And now let's do Python trainer.py config.yaml. Boom! GitHub link in description is a dead link. Oh, I hope not. Oof, no. All right, so we're running this. Let me double check the what you're talking about. So github.com, AI Advocates Rochambeau is where the project is. We actually created this project. I'm supposed to put stuff in here that I'm supposed to do. Oh, we're still working on it. Oh, I'm still doing that a little bit. We should put more stuff in here. I should start at the beginning. Remind me all to do this the right way so that everyone's like, what's going on? Okay, so it's running. There's the loss. Get out of the way. There we go. It's doing its thing. It's learning. It's And then what I want to do is I'm going to run all these again because I want to have, maybe I don't need to, but I want to have like this in there, like size. I wonder if I can, yeah, see all these things that it logged, I can have them in there and then I can just have them in here and we can just like do a direct comparison. Let's do that. So what I'm gonna do is I'm gonna archive, I'm gonna delete all these experiments. Yes. Goodbye. Goodbye. And then we're gonna just try this again. And now I'm logging it out explicitly, I think. Oh no, I'm not. Oh, whoops. Generator has no type of length. I should have known. Let's ask. PyTorch get parameter number. Dude. Interesting. So I was kind of right. What does numel do? Torch.numel method returns the total number of elements in the input tensor. Okay. That stands for number of element. So there we go. Genesee, what are you asking? Learning the loss go lower. Are there size? Yeah. What I'm trying to do is I'm trying to get the number of parameters and the file size. And then I also got a self.log model, and then it would be self.model type. Where'd model size come from? Model size. Where's that even? Who's doing that? Okay. This works. So this is a problem. So let's just do this. Let's go with Stack Overflow. I mean, why wouldn't we? Let's do this. Self. Okay. We're putting that in the thing, so it's all in there. This won't break our other thing because we're only looking at the classes. Let me double check that here. Score. Yeah, we just get the classes. So it's not going to make a lick of difference. This we save. This we save. Let's run it again. Try it. See if it works. I guess I should have tried it with just one epoch, but I didn't do it. So as this trains, let me explain what's going on. Basically, the image goes into this huge like sink, right? And then it gets chugged. All the pixels get multiplied, and things happen. And then at the end, there is this vector that comes out of size 4, and I think it's none, rock, paper, scissors. And what you do is you look for the max index, so the index with the highest number. And if it's in here, you guess rock. If it's here, you guess paper. Here, you guess scissors. And so this machinery here is what we call the model. And so the way that it actually makes the model is there's a bunch of numbers in here that it needs to know how to multiply things in there. You know, it multiplies like numbers. Like there's a number it picks here that multiplies by like the red channel and then it does like it's like a big washing machine, so to speak. So these numbers that belong in here, in order to find the numbers, it goes into this huge loop of like trying a bunch of pictures and seeing how good it is at it using the loss function. And it just does this loop. And that's what this loop is doing, is it's going through all the pictures, updating the numbers, and finding better numbers so that it can do it. Crap. What is going on? Self.trainer results. What? Line 68. Medium rare is warming up. Indeed. Exactly. But what is this? You know what? We're gonna have to debug this son of a gun. Let's go to debug. I put a little break size on there. Figure out what's going on. Got to figure out what's going on, and then we'll try some param size. Param size, yeah. What the heck? Oh, stop it! Oh gosh, this happens sometimes, and it's like your GPU isn't ready. You're a liar. That was scary. But it works now. Hey, yo. Boop. Here we go. And now I'm debugging it so that I can see what's going on. I should have done this at the beginning, but, you know, cooler heads did not prevail. Yeah, everyone's like looking at this like, oh, so this is how you do AI stuff. Yeah, you sit around and watch things. And just what was the trainer 18 after fit? Line 68. This. It's supposed to be an int. But maybe there's something going on here. Yeah, so sometimes the GPU is a little finicky when I debug. I don't know why. I don't know. And I know the warning message. The warning message is like, everything is exploding. You're gonna die. And the first time I saw it, I was like, something is destroyed. Yeah, I know, but it wasn't. It's just something happened when it tried to grab the GPU. I don't know. It always works the second time. If it ever doesn't work the second time, then we'll know things are in trouble. Okay. What do we got here for param size? Let's go to debugger. Param size. The freak, man. It's fine. What did I do? File size. Let's see. F10. Yeah. File size is in there. Psh. Psh, psh, psh. So what's the problem? What? Maybe the log is done. Maybe the log has been discarded. What is this for? Maybe the log has been discarded. I want to log it, though. I want to log it. I'm going to log it. I'm going to log it. Import ML flow. We're just going to ML flow log it. Let's just, you know what? If you don't want to do it, then I'll force you. ML flow. Log metric. Yeah. I'm just going to do it. I'm just going to do it this way. But I'm. Oh, you know what? I'm just going to do this. If we can. By the way, MLflow is a open source, logging utility. Blog text. That's what I need for this one. Boop. I wonder in the trainer, is there logging happening? Nope. I'll just call MLflow log. Oh, this feels dirty. Doesn't this feel wrong to you? This feels wrong to me. Feels wrong. Should I just return these parameters in a tuple? By the way, is it tuple or tuple? Tuple or tuple? I don't know. Will the world ever know? So I'll just return these. Return param size, file size. Tuple. Either way. So let's go to the trainer here. Param size, model size equals, and then we'll MLflow log this. I guess it's file size. And this is going to be model.model type. Okay, that way we've taken anything that could blow up out of there. Let's see if it works. Alrighty, we'll debug again. Debug again. Here we go. Oh! Run it again. Maybe because there's an exception, it doesn't release the handle to the GPU. I don't know. It's like, there's no GPU. You lie. You lie. I guess I don't need this anymore. I guess I could get this number. I don't even need to pass this back either. This thing. I can get that from the model. Just the file size. Let's do that. Doot. We'll call it model params. Model params equals doot. Numel for model dot parameters. Doot. And that way, the only thing that gets back is the file size. Let's go back to le model. Yeah, but that sucks, right? Because I'm doing it here too, so I might as well just I'll just leave it. Yeah, I'll just leave it. Beep 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 beep. That way I'm not doing it twice. Luca's GPU is always busy printing money. Dang, bro. F10. The heck? F5. What? Step over. Why is this taking so long? F5. Go, 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 go. Stop. Dang it. What the freak happened there? That was weird. Do it again. Maybe it's time to just push it to the cloud. As long as it doesn't have an error. then we're good to go. Here we go. Things are happening. Yeah, that was weird. Well, I didn't break anything. So, just for what it's worth, we're outputting more stuff to get sense for size and parameters. That way we know what's going on. The goal is to hopefully get them all to show up here, so that we can see at a glance. We can try every single model, look at all of them. You know, do what us data scientists are supposed to do. Here we go. It gets to about 18 and then it stops. Hopefully next week, I talked to some of the Onyx people. Hopefully I'll try to get them on next week. I know Cassie knows about Onyx stuff, and so maybe she can help me. Because she's the bomb.com. All right, we're at Epoch 11. It's learning. Oh, Seth, things are happening. Me. No, they ain't. Hey, this thing's got to break a couple times before, you know. It's how we earn the medium to small dollars, friends. Yay! Medium to small dollars. No bomb sound effects. What do I got here? I have crickets, air horn. Oh, jeez. I hope it just... Oh, there we go. Now it works. Okay. All right, so we know this works now. Perfecto. So let's do this. Let's submit a whole bunch of them. Let's do all of them. We'll submit them all at a time and let Gandalf, my cluster in the cloud, do all the work. Okay, so let's go over here. Let's take this. We don't need this. We don't need this. We just need this one. Right. We'll split right here. And what we're going to do is we're just going to change models. We don't need this. Oh, what is this? Dataset Rochambeau does not exist in Workspace. Like heck it doesn't. Let's go to datasets. There you are. Rochambeau. Fibber. Are we in the right space? Yes. Let's take a look over here. Look at our machine learning workspace datasets. There you are. I don't know what you're talking about. You're right there. Look at that. Don't lie to us. Don't lie to us, because we'll catch you in the very act. Okay. Let's put this over here. So the first thing we're going to try is we're going to try a ResNet 18. So that's the first one. So we'll save this one, and then we'll right-click, and we'll create the resource. And we're just going to run a whole bunch of them and watch them go. Like we're at the dog track or something, watching these things go. Oh, and the other thing I did, remember, is I just put one layer. I just took I took out the extra fully connected layer because, you know, who cares? Nobody cares as long as it works. Luca bets on number 4. I guess it's uploaded, so we can change it now. ResNet 34. Should we do the full like ResNet 101? I'm curious. Anyone else curious? I'm curious. 3.2 gigabytes. You got to be kidding me. There's no way it's loading that much. All right, let's create this one. ResNet 34. Let's go to Rochambeau here. Oh, no, that's not what I want. Chom. Chom. Here we go. There we go. He's running. Running. Run number 6. Okay, did we start the other one? Yes, we did. ResNet 34. Let's do ResNet 50. ResNet 50. Everyone's like, Seth, you're running a bunch of GPU jobs in the cloud. Yes, I am. And I am not ashamed that I'm using computational resources at the moment. I mean, if Luca can use it to print money, I can use it to have it look at pictures of me. Although one is more upsetting to the computer. All right, there's this one. Let's take a look at this. It's not done. So the tag should show up there at the end. I'm hoping. If it doesn't, then poo on me, right? Okay. There's run number 8. Let's do the next one. ResNet. Should we just do like a bigger ResNet? ResNet. Should we do the ResNet? Should we do the 101? Let's just do it. You know, I mean, we're all friends here. Let's just do it. Jay's like, which one is the one that upsets the computer? Well, the one that looks at pictures of me, of course. ResNet 101. I bet that one takes the longest. All right, let's see if our computer is spinning up here. My compute cluster is called Gandalf. It's running 1. Oh, look at that. It's like, oh no, I need more. We need more power. I'm giving it all she's got, Captain. We need more nodes. Just give it more nodes. We need more power. By the way, if y'all are watching this and you're like, what the heck? I want to run all of these models, all of them, so I know which one's the best one. There's no way I'm going to do it on my machine unless we're all just going to sit here and stare at each other awkwardly. Although we can. So I'm just making Gandalf do it, who is a wizard. Each of his machines has an NVIDIA K80 anyways. So we can do that. Okay, we just ran the 101. Let's go back to our experimentos. Rochambeau. This one is the ResNet 101. Should we go higher? Let's do it. Let's go higher. ResNet 152. I bet it gets worse. I bet it's not even worth it anymore. And it just occurred to me, dang it, that we have something. We have something that goes through all the parameters and like, what's it called? Oh shoot! I should have just done that. Maybe next time. All right, so we've gone through all the ResNets. What are the other ones that we can do here? Should we do an AlexNet? What do you think? AlexNet. One weird trick. Someone in 2014 was really looking for the SEO there on that. You see that one weird trick? Smart. Who wrote this? Alex Krzyzewski. Genius. Let's try a little AlexNet here. Going through all the parameters is called a for loop. Yep, exactly. AlexNet. Let's try AlexNet in a VGG16. So, AlexNet. And then we'll put you in there. Is it better on YouTube? I wonder why it's not so good on LinkedIn. Bruno! Obrigado. That's all I can say. Portuguese for you, buddy. Okay, how's it going? Wow, y'all are still queued? What the heck? Psh. Psh. Computer! Awake! Oh, it's still resizing. Awake, computer. Oh, you gotta do some squeeze nets. Let's do VGG. There's a VGG 16 and a VGG 19, right? They only have VGG 16. This is already uploaded. We can do the next one. Dot B G. Oh wow! I don't know if I want to do all these. That's a lot. That's a lot. Oh, by the way, some of the shuffle nets don't work. I tried a shuffle net the other day. I got to see which one it was that I did, because I don't want to use the wrong one and waste compute resources. Says the guy just running a. says the guy running a a ResNet 1,000 million. Let's see if I can find it here. I had it on Teams. I'm looking on my pad here. Where is it? Here we go. It's in my email. I remember. Because one of the squeeze nets does not work. Because it doesn't have pre-trained things in there. And it just barfs on me. Barfs on me every time. Let me go to my email. Find it. And as you're doing that, let's take a look at how this horse race is going. How's the horse race? Oh, look at that. Let's see if we can't add a column for... oh, jeez. Max. No. Let me go into the actual experiment here. Why did it not show it? Wow, it didn't show up. That's lame. Oh, why? It's definitely in here, though. Oof, that's pretty crappy. Why didn't those show up? I thought I did everything right. Okay, let's add it ourselves, though. Maybe I didn't do it in the right spot. I mean, like, it should show up somewhere. There's all of them. I guess I'll just have to put them in myself. So meta. Let me see if I can't. Let me do this so that I can have them both open at the same time. Okay, so for this one, thank you all. I'm just gonna take all these off. Nobody cares about this. Okay, so we have model, and then we have a ResNet 18. Add. And we have params. Oh, jeez. I wish I didn't have to do this. What did I do wrong? Add, and then we'll do a size. Okay. And then we'll just... I don't want to do that. That's a bummer. And what I can do then is, let me edit the columns here. Let's see if it's in there. There's mode, there's start time, there's display name, experiment, node count, run ID, patient parent run ID. Dampening debugs. Yeah, that's kind of dumb. Let me refresh this. It's supposed to show up in here, but maybe it takes a little bit of time to do that. Okay, so model on it. Here, I'm looking at my email here. The one SqueezeNet one that worked. Oh, here we go. I think it was like. Dang, where was it? Or maybe it was in Teams. But there was a version of the SqueezeNet that I had to use, otherwise it broke it, and I just did not like that. But let's do a VGG 16 and a VGG 19. No, let's do VGG 11. Here we go. Create resource. Oakley dokley. VGG 11. I don't know why it's not outputting the log, too. That's kind of making me grumpy. Because it feels like I got to do a lot of busy work now. Oh, bummer. Bummer. Let's try the edit columns here. And let's see if I can find the model. No, it's not yet. All right, let's go to run number 7. Run number 7. Run number 7, you're done. Outputs logs. I don't want to do this, but... Alrighty, ResNet. Boom, 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 boom. I did something wrong, and so that's why I have to do this. I don't want to run these again, you know? Okay, and then finally the size. Okay. Now let's go back here, and maybe it just needed 2 of these things to do it. Dampening, momentum, Nesterov, accuracy, params, size. What's the size thing here? I think this is the size. Maybe it is logging them. Let me see my code here. Let's go to the trainer here. Tell me what you're logging. Yeah, so size, params, and model. Let's go to this experiment here. Over here. Log size, it seems. Discard. Let's go to the metrics. I don't know where it's getting size from. Where are you getting size? What's this weight count? Details. 3 minutes. Registered model. Metrics. Descripción. Outputs. There's the model parameter, model size. Oh, this is all in here. Huh. I'm already outputting this. Why am I not logging this somewhere? I think maybe I'm logging it incorrectly. Maybe. Perhaps. Okay. What do we got going on here? So let's go to the columns and let's see if I can find patients. I am not finding param. Oh, here it is. Huh. Ha 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 ha. Hey yo. I think we may have I wonder. So it's logging it, but we're not seeing it, which is weird. And then model. Because if we do this, oh shoot, I thought I just moved these. Oh, I didn't save it. So we'll go here, and we'll go here, and then we'll hit save. Then we'll move this. No, we don't. We want this to fit. Why is this so? Why is this taking so long? What? We don't need this favorite thing. We need submitted time. I don't care. Duration is important. Submitted by. Psh, who cares? Compute target. I don't care. Okay. So let's save this. Because I think this is interesting. What's interesting to me is that it's not showing up here, which is weird. But it's showing up here, which is weird. Let's go to run 10. What is this? Oh, I know what's happening. Oh my goodness, I know what's happening. It created a whole new experiment. Because I started a brand new logging thing. Yep. Oh, that's dumb. I need to clear those out. This is no bueno. No bueno. I remember this happening. When I do mlflow.log metric, it thinks it's a new experiment, which is not good. It's not good. So what I need to do... Okay, I just totally messed all this up. Because you're seeing that it's doing a bunch of different experiments, and some of them are done like in a second. It's because it's logging out these things, which is not a good thing, right? And so that's what happened. So let me go here, and let's see if we can add tags to this before we do anything. All right, so something's not right here. I'm gonna take this out. Just do this. I have to fix this. I don't know what. I made like this big mistake where I'm like, for some reason, MLflow is creating a brand new experiment. It's like, oh, a new experiment. So that's what's going on, which really sucks. Oof. So what I need to do is I need to log here. This is where I need to log or tag, right? Dot. Oh, how do I do that? How do I get it beforehand? Oh, maybe here. Def before fit. I know I did this before, so self.model dot or self.trainer dot model. There we go. Model. What do we got in here? So this is where I get all of the information. And then I can do like a self.log. Or is it log? How would log stuff here? The thing is, I'm doing auto log. All right. We're going to have to look up this auto log thing. Okay. MLflow auto log. PyTorch. Okay, here we go. Auto log. Interesting. 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 There's got to be a way to what is this other part? Yeah, because I don't want to. This feels like I'm. Oof. Like, how do I log params out using ML Flow? There we go. Automatic logging. Use the log method and callback, except for batch start names. Looks like there's a custom logger. No. When training a model, it's useful to know what hyperparameters are in the model. When Lightning creates a checkpoint, it stores a key hyperparameters with some loggers also allow logging the hyperparameters using the experiment. For instance, when using the test tube logger or the test tube logger, all hyperparameters are each parameter. Maybe it's this. Because I tried the self.log, remember, and I think it broke. So let's get this out of here. And let's go to the model itself. Where did it put this? No. You know when you have like way too many browser windows open? No. So we did this. We did this. We got that. We got that. We can close that. No. Where did that other thing go? Here. Log hyperparams. If you want to track a metric in TensorBoard H params, tab log scalars to the key HP metric. Tracking multiple metrics, initialization, blah, 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 blah. So let's do this. Let's do this. See what that does. So this would be in the trainer. Close you, close you. I wonder why I can't do this. Let's control Z. Oh. Self.logger. It doesn't have a logger. Where did it get its logger from? Let's see here. If you want to track a metric in okay. We're using the ML Flow logger with Autolog. All right, let's see what we got going on over here. Always learning something. Let's see. No, what is it? What do you even have in here? Trainer dot logger. There it is. Dot log hyperparams. I guess I'll just say meta because I don't know what else to do. And then what we'll do is we'll do this. Let's try this. Let's just run more of these and see if this fixes it for us. Because, I mean, it'd be nice if we just like have this stuff in there. I don't have to really write it over and over again because that would suck. One more time. Model. I think this will do it, right? Let's try with the smallest model. What was it? ResNet 18? Let's do a ResNet 18. We ran so many of these. I feel so wasteful. You know, you live and let learn. Job. Create resource. Let's go back here. See, I think what's happening is because I said mlflow.log, what it's thinking is it's a whole new experiment, and it's creating a new experiment instance, which is really not cool. So, oh, by the way, look at that. So number 20 is the one we want to see. And we're going to see some hyperparameters. Here, let's see what it did before. Let's go over here to one that it did before. Run number 9. These were params. Maybe I should have done params like this. Params. We'll try it again with params. Params. And let's just run this twice so it's in there twice. See what happens. Okay. Running number 20. Oh, all machine learning all the time. Any questions, by the way, from all you lovely folks? Lovely folks. I'm wondering if like a meta is going to show up. How am I doing? Great. It's Friday. Yay. We're going to have a good time watching some Ted Lasso. Pretty excited about that. Okay, refresh. I'm trying to see where this other stuff is going to show up. Let's go full screen here. You can see the full screen. Fry, yeah. I know Ted Lasso is great. Is this still running? What we got? What we got going on here? No, it's not done yet. It's not done yet. It should be done in like, what, 3 minutes? Ah, it's 12:30 already. Bananas. Wow, this has gone by fast. Refresh. Hurry up. Pro jumbo. 2 minutes 31. Last time we ran it, it was 3 minutes 14. So we got another 60 seconds. Oh, finalizing. Let's go here. Oh, what happened? Run details. Maybe it didn't like 3:30. Let's see what it didn't like. Oh wow, what the heck? I should have ran it locally. Embarrassing. Let's try to run it local. So let's do a little plusy plus here. Conda, activate torch. We're gonna get this logging working. Params namespace. Args. Quargs. I think yeah, something is not right with this. I think my other one's going to fail too. Yeah, what the heck? What's going on here? Do. Okay. So it says trainer, debug after fit, self logger meta. Element 0 has length 1. 2 is required. Huh? If you want to track metrics, H params. What is self.h params? Oh, whoa. Oh, whoa. I think I have something for that. Self dot h no psh, self dot trainer dot h params. Where is it? Where are they getting this h params from? Oops, wrong one. Self.h params. you want to track, if you're tracking mobile metrics, initialize some of the default age profiles. I think I'm holding it wrong. You can see right here. Dictionary updates equals 2 is required. Yeah, there you go. So J is like from the model. Let's try self dot trainer dot model dot h params. But the other thing that's interesting to me is that, let's try this again while it's loading, and then we'll tinker with it. The other thing I'm wondering about is it says I have to do it at the beginning. Tracking multiple metrics, initialize blah blah blah, and call log height only once with your metric keys initial values. Subsequent updates can still be logged to the metric keys. For the following example, set up properly. Metrics. Oh, Jay found something else. Oh my goodness. Boop. To be fair, we're saving the best one, so we should do this. This should be the right answer. Now that I think about it, right? I mean, I guess it doesn't matter, right? Because it's the same. They're going to be the same for all of them. But that would be the right thing. Look at this. Looks like we spent the whole time doing machine learning. Hopefully everybody knew that like this is what machine learning was, because everyone's like, what the heck? I thought there'd be like unicorns and rainbows and butterflies. No butterflies today. None. All right, epoch number 5. Maybe we should have like did a little break here. Self.trainer.logger.log hyperparams. Yeah, we did get unicorns. We indeed. Yes. Yes. All right, let's see what this does. Of course. But at least we got a unicorn. I am indeed a unicorn. That's why I always try to face forward so that my horn doesn't show. Because, oh, jeez, what the freak? Well, this is definitely usable. It should be a way to enter model properties into the metadata for easy review downstream later. Think about a week from now, you want to... Exactly. I know. But looks like these hyperparams are all scalars, which is odd to me. Let me go to one that worked here. So let's go to number 9. Like, these are not scalars. I wonder how we do tags. Maybe we can do tags? I mean, Let's ask it. Tags. That's it. Huh. That's a bummer. So let's go here. Lightning supports puppy long blah blah blah. Choose running from all flow blah blah blah. Let's say ML flow tags. All right, let's see what we got here. Okay, self.trainer, .trainer, logger dot tag. What do we got? Log hyperparameters, close, log graph, log metric, savedir, version, sanitize. Now we're into the dunder methods. Dunder. What do we got in here? Nothing. Nada. Yeah, I'm not finding the thing that I want. Maybe it's because it's the before fit. I don't know. What do we got in the auto log? Huh. I gotta watch the clock because we got 15 more minutes. Interesting. This is just the documentation. Nothing new here. This is the one that we want. Yeah. Jay is saying, makes sense. Wouldn't want to know. So before fit, we can see what we do after fit. Yeah. I mean, but you kind of do by, you kind of do just because you know how many parameters are in the model, then you multiply by what, 16? And that's a good estimate. So I don't know. That's the problem, right? Like, I guess I could do before training. Let's try that. Let's try before training. Def before. Is it here in the model? Is it in the model? Where do they do it over here? It was down here. Params. Oh, this I didn't know. That's pretty cool. On train start. On train start. Let's try that. On train start. Def on train start. Is there a super? Do I need to worry about the super? Is there a super? Let's go to the lightning module and see what it looks like. ABC optimizers, LR schedules, on train. Oh no, I guess it's not in there. I'm not gonna worry about it because I don't need to. I don't do it here. So let's do this. Log. Okay. So this is what we can do because this stuff is. We can just set this up immediately. And we can do here. Param size equals. I think we can do this right now because we know the parameters, or at least I can set it to 0 first, right? And then on train start, I can say self.param size this. Okay, so we have that. So I can say self.log string value. So parameters, parameters, and then we can say self.param size. Okay, and then we can say self.log, and then we'll say model, and this model will be self.model type. So we can do that. I wonder if that's enough. Because now we can just say self.param size. File size, I'm not going to get until I print it, right? And this is where I'm like, what do we do here? Self.log. Why didn't this work? Do we remember? Let's try this and let's see if it works. And let me change this so that it's not taking so long. We'll do it in like one epoch. Patience. Because I'm doing early stopping, it's just, I'll just leave it here for now. All right. Everyone's like, why are we spending so much time doing this? Well, it's because it's part of the experimentation. Experimentation. Here we go. Why can we not log strings? I think that's the logger type. Is there like a log string? Oh, I'm in the wrong spot. Why am I even there? Here. this. Ooh, only on the trainer. Yeah, check. Well, what am I doing? Yeah, when I model, when I'm logging the model type. Oh, at the top of trainer.py. Let's go to trainer.py. I'm not doing that. Oh, it's this that's a problem. This problem. Oh, wait a minute. It is, isn't it? It's a string. I thought it was a string. Go to def. Let's see what type it is. It's a string. Yeah, it's a string. Maybe it's this that's angry. Let's try this. Thankfully, this should be able to error out quickly. Yeah. It's this string thing. Okay. Let's look at this over here. Self.logger. I am not getting what this is. I think it's because because it may be null. And so what's happening is it's like self.logger log was it log string? Let's go to get out of here. Let's try that. Self.log trainer dot logger dot what is this logger dot log or a tag? Is there a tag? Log hyperparams, graph, and metrics. The heck? Something is awry. Oh my goodness, it's almost time to go. I need to look into this because this is a bummer. Self.trainer.logger. Oh, on train start. Maybe this is what it's saying to do. Oh no. Yeah, looks like they meant this. Maybe they meant on train start here. Def on train. But it's not. I don't see that there. I didn't see it in here. Hello, my friend Mohammed from DXB. I don't know where that is. This is gonna make me cranky. It's time to put on the walk-off music because it's almost time to go. By the way, next week, more goodness on this. I'm gonna do some research. I'm gonna try to get some of the folks that do WSL. Maybe there's a better way to do this with WSL. Also, want to talk to the Onyx people, see if we can get some of our inference code done. I really want to get a really good, tiny model that's really fast, but I need to have a basis for comparison. So before next time, I'm going to clean up my experiment area. That way it's not so polluted. And figure out this dumb logging thing. Because it's easier to do stuff when we have a list of things and we can really take a look at like what model should we use? Which one's the best one? So let's see. Just to finish up here, I just don't understand why. Oh wow, I am using PyTorch Lightning, the bigger version. Maybe I should upgrade my ML flow. There's gotta be a way to what's K? What's R? Oh, I see. Yeah, there's got to be a way to add to this params dictionary. You know? That's what I got to do. I got to figure that out. Until then, my friends, it's always a pleasure to be with every single one of you. Learning about AI. And like I said, if you have any questions during the off-season hours, just email me or send me something over Twitter so that we can help you out. But as always, thank you so much for spending some time with us to learn all about AI. It's been fun, and hopefully, my friends, we'll see you next week. Take care.